Hi everyone. In this video we are going to discuss this example. So we have a complex integration here. We have to solve it with the help of Cauchy's residue theorem. They have mentioned just residue theorem, but it is Cauchy's residue theorem. First of all, I will call the given integral as I and then we will start to solve. So what is I here? We have I is equal to integration over c sin raised to 6z upon z minus pi by 6 raised to 3 dz. So this is a given integral. Okay, so the most important part is that curve C. Let us draw that curve first, then we will solve the remaining part of our problem, where C is mod z is equal to 1. So what will I do? I will find the center and radius of this curve. Actually it's a circle, getting it's a circle. To draw the circle, we need to know the center and radius, so we can easily find just by comparing with standard form of a circle. The standard form of a circle is mod z minus z naught is equal to r. So this is standard form of a circle. Here center is z naught, radius is r. See, in a given equation of circle, we have simply mod z. That means it is actually in this form. Z minus 0 is z itself, so that's why they are given z only. So if you compare, you can easily see our z naught is 0 and our r is 1. That means center is 0, 0 means 0, 0 and radius is 1. Okay, so its center, I should mention it is a circle, so it's a circle. Center 0, 0 and radius is 1. So what will I do? I will draw this circle first. This is imaginary axis. This is real axis. Okay. Center is 0, 0. Let us have some scaling. 1, 2, minus 1, minus 2, 1, 1, minus 1. Okay. So we have a circle with center 0, 0, radius 1. That means we will have a circle like this. Okay, let me draw properly. So this type of circle we have. Okay, so after that we should consider the given function. That means whatever we have inside this integration, that is our function. We will call it as f of z. Okay, just a minute. Let me remove this part, it is not required now. We have f of z function is sin raised to 6z upon z minus pi by 6 cube. So this is a given function, right? We have to solve this integration with the help of Cauchy's residue theorem. So let me tell you what is Cauchy's residue theorem and then we will plan how to solve the problem. Okay. So Cauchy's residue theorem is integration over c f of z dz 2 pi I sum of residues. That means according to Cauchy's residue theorem, what we do, we find the singular points of a given function. Singular point, that means a point where function is not analytic, or generally we say the point where the denominator is 0. After getting those points, we check whether those points lying inside circle or outside circle. Getting? Okay. So if any point lies outside, no need to worry. No need to calculate any residue at that point. But see, if any point lies inside C, then we have to calculate residue at that point. We have to find out residue at all singular points which are lying inside this curve C. Then we take sum of all such residues, we take the product with 2 pi I and then we get the value of that integration. That means we get the value of integration with the help of residue. So the same method we are going to follow here, right? So obviously our next task is to find the singular points of this f of z. That means a point where the function is not analytic, or generally we say the point where the denominator is 0. You can easily see in a denominator we have a single bracket z minus pi by 6. If I put z is equal to pi by 6 here, pi by 6 minus pi by 6 will get cancelled to each other and we will get denominator 0. That means pi by 6 is a singular point. Let me mention clearly. F is not analytic if z is equal to pi by 6. Since if I put z is equal to pi by 6 minus pi by 6, 0 we get in denominator. Okay, so that's why function is not analytic. We also call it as singular point. Now the next task is to check whether that point lies inside or outside the circle C. Pi means let us find its rough value. Z is equal to what we have, pi by 6. Pi means 3.142 divided by 6. If you divide that number by 6, you will get approximately 0.5, okay, and 2 and something and so on. So its value is approximately 0.52. 0.52, that means it will be here pi by 6. It means it lies inside curve C. It means we have to find residue at that point. Okay, so let me clearly mention here. It lies inside C. So we have a singular point pi by 6 and it lies inside C. So our next task is to find residue. Now the question is how to find residue. So we have a definition of residue, we can use it and we can find residue. But see, it's a very hectic task since it involves Cauchy, that Lorentz series expansion. So it will take more time to find the Lorentz series expansion and then residue. If given singular point is a pole, then we have a very simple formulas to calculate residue. And fortunately it is a pole and its order is 3 since that bracket has power 3. So let me clearly mention first here, Z is equal to pi by 6 is a pole of order 3. It's a pole of order 3. So that's why we can use that formula to calculate residue. So residue of f of z at z is equal to pi by 6, that formula says, okay, I will write the formula first and then by putting values we will get the answer. Okay, the formula is 1 upon n minus 1 factorial limit z tends to pi by 6. It is a singular point, n minus 1 derivative z minus pi by 6 raised to n f of z. So here the value of n is 3 since this is a pole of order 3. So at a place of n we have to put 3 everywhere. So 1 upon 3 minus 1, that means 2 factorial limit z tends to pi by 6, n minus 3 minus 1 2. So we have to take second derivative, z minus pi by 6 raised to 3 f of z. So obviously we have to put the value of f of z here. Okay, see there is no more space to write, make a screenshot of it first, then I will go further. So let us simplify it further. Okay, so this is equal to 2 factorial means 2 into 1 2 limit z tends to pi by 6 second derivative, okay, z minus pi by 6 raised to 3, okay, f of z is sin raised to 6z and in denominator we have z minus pi by 6 cube, okay. So now we can easily cancel this z minus pi by 6 cube, z minus pi by 6 cube. So those brackets will get cancelled to each other and we will have simply sin raised to 6z. So let me write 1 by 2 limit z tends to pi by 6 double derivative of what we have inside the bracket, sin raised to 6z. Now it means we have to find two derivatives of the same function, double derivative, getting? So first I will calculate first derivative and then I will go for the second derivative. Step by step we will calculate derivatives. 1 by 2 limit z tends to pi by 6. I am writing first derivative outside and I am going to take its derivative. Actually there is not only sin z, it has some power also, sin raised to 6z. It means we have to use this formula first. Derivative of x raised to n is n x raised to n minus 1. This formula is applicable first. So by that formula I should write 6 sine raised to 5z. Since what we do, whatever the power we have, we write it first and we reduce the power by 1. Doing the same thing here, I am writing the power first and I am reducing the power by 1, it means 5. Okay, into. See, we have taken the derivative of power only, still we haven't taken derivative of sine. Derivative of sine is cos z, it is called chain rule. That means we take the derivative of outer function first, then we go inside and we take the derivative of inner function. So I use chain rule here. So 6 is constant, you can take it outside. It will directly come outside, getting, since it is constant, but it will get cancelled by 2 and we will have 3 only. 6 by 2, which is 3. So limit z tends to pi by 6 derivative of sine raised to 5z into cos z. So this is equal to 3 limit z tends to pi by 6. Okay. See, multiplication is there. We have two functions and we have a product of these two functions and then we have to take its derivative. So when we have product of two functions inside the derivative, we go for u into v formula. It says first into derivative of second plus second into derivative of first. I am going to use that formula. So that formula, sine raised to 5z derivative of what? Cos z plus cos z as it is derivative of sine raised to 5z. I am writing here properly sine raised to 5z, or I am sure it is visible to you now. Okay. So what I have done here, I wrote the first function as it is derivative of second plus I wrote the second function as it is derivative of first. So this is u into v formula of derivative. Okay. So there is no more space to write, make a screenshot of it first, then I will go further. So let us find derivative now. Okay. 3 into 3 is constant, 3 limit z tends to pi by 6 sine raised to 5z as it is into derivative of cos z, which is minus sine z, plus cos z as it is into, now we have to take derivative of sine raised to 5. There is not only sine, it has some power also, raised to 5. So we have to take derivative of that power first, getting. So derivative of x raised to 5, let me tell you, derivative of x raised to 5 is 5x raised to 4. Whatever the power we have, we write it first and we reduce the power by 1. Using same formula I get here 5 sine raised to 4z into, again derivative of sine. Since still we haven't taken any derivative of sine, we have simply took the derivative of power. So derivative of sine is cos z. Okay. So what will I do? I will write it properly and then I will apply the limit. Limit z tends to pi by 6 minus sine raised to 5 into sine raised to 6z plus 5 sine raised to 4z cos into cos square z. Okay. So let us move further. So this is equal to 3 limit. Okay, now what will I do? It's time to apply the limit, no? Apply the limit, that means simply at a place of z I am going to put pi by 6 everywhere. So minus sine raised to 6 pi by 6 plus 5 sine raised to 4 pi by 6 into cos square pi by 6. So now we have to put the values of sine pi by 6 and cos pi by 6 everywhere. Okay. Using calculator also you can easily find sine pi by 6 is 1 by 2. So it is 1 by 2 raised to 6, 5, sine pi by 6, 1 by 2 raised to 4, cos pi by 6 is root 3 by 2 square. So 3, 1 raised to, I am taking a separate power of numerator and power of denominator, minus 1 raised to 6, 1, 2 raised to 6 is 64, 5, 1 raised to 4, 1 itself, 2 raised to 4, 16, root 3 square is 3 and 2 square is 4, it means 3 minus 1 by 64 and 15 by 64. See, fortunately both terms have a same denominator 64, so we can add numerators. 15 minus 1, 14. So 3 into 14 by 64. See, both are further divisible by 2. So it is 7 by 32. 7 into 3, 21 by 32. Okay, so this is required residue. So fortunately we had just one singular point. It was lying inside circle. So it was necessary to find residue and we got it. It is 21 by 32. So it's time to apply Cauchy's residue theorem. But see, there is no more space to write. Make a screenshot of it first, then I will go further. So by Cauchy's residue theorem, let me write here, by Cauchy's residue theorem, integration over C, what we have in integration sin raised to 6z upon z minus pi by 6 cube dz is 2 pi I sum of residues, getting? So 2 pi I. So here we have a single residue which is 21 by 32. See, 2 will get cancelled and we will have 21 pi I upon 16. So this is required value of integration. Make a screenshot of it, then we will stop. Thank you. See you in next video.